What if space isn't expanding everywhere at once, but being stretched from the inside out by a hidden sphere, a mind inside the universe blowing the bubble bigger and bigger?
Today I'm chasing a wild idea.
To poke at a real mystery, the Hubble anomaly. Our best measurements of how fast the universe expands don't all agree. Something's off, either our tools, our models, or our assumptions. The speed of light is changing. It used to be 186,181, now it's 187,746. Sounds dramatic, right? It's also wrong, at least in the way it's framed. Here's the twist. Those numbers were people measuring with imperfect tools, often mixing up miles per second and meters per second. The real headline is this. By 1983, measurements got so precise scientists flipped the script. Instead of measuring how fast light goes with a meter stick, they defined the meter by how far light goes. Boom! The speed of light became a built-in constant, exactly 299,792,458 meters per second. No rounding, no wobble. So if anyone runs an experiment today and finds a different speed of light, that doesn't mean light sped up. It means their meter stick, or their timing, was off. Because the meter itself is now pegged to light's speed. That's the reveal. But wait, what about the expanding universe? Galaxies drift apart, space stretches, wavelengths of light get longer. Doesn't that mean light's speeding up or slowing down? Not locally. The expansion of space redshifts light, stretches its color, without changing its intrinsic speed where you are. Think of it like dots on a balloon. As the balloon inflates, the dots separate, but the ink on each dot doesn't suddenly rush faster. Light still zips past you at sea. Historically, scientists did see different values. 220,000 miles per second, 186,281, 186,500. Each was a snapshot of our instruments getting better and our definitions tightening. The pattern wasn't a changing universe, it was a sharpening ruler, and that's why 1983 matters. We stopped chasing CE and anchored our measurements to it. Define the meter by light, and you lock in the limit that physics keeps pointing to. If you've been exploring a kinetic grid model, imagining the universe as a kind of pressure mesh, these old swings are still valuable. They tell a human story. We kept poking the grid from different angles until we realized the grid pushes back the same way, every time. C shows up as the universal speed limit, not because our tools want it, but because reality insists on it. So did the speed of light change? The numbers did. Our definitions did. Our confidence did. But light? Locally, it's the rock we built the meter on. 299,792,458 meters per second. Exactly. The universe expands, wavelengths stretch, distances grow, and CE stays the line you can't cross. That's the trick. Start with the wrong headline, end with a better ruler. And once your ruler is made of light, everything else snaps into focus.
Welcome to the kinetic grid model, where the universe behaves like hardware running on pressure and information. In this unified node theory, space is a grid of massless nodes that process energy instead of moving. A 2.1 expansion ratio is the universe's pulse. 1 unit of internal pressure, 2 units of outward expansion. HPS, the high pressure system, is the measurable squeeze that shapes motion, mass, and flow. Let's survey the components. Nodes, the carrier force, the gravillient effect, and space as a pressurized medium. First, the kinetic node, immutable, massless, and fixed. Galaxies are anchors within this lattice. When a galaxy seems to move, it is not traveling through space. It displaces the grid's pressure gradient. Survey method, observe node displacement. Track gradient shifts, not paths. The 2:1 ratio is surveyable. 1 internal pressurization begets 2 units of outward expansion. This reframes kinematics. Motion is a bookkeeping of pressure differentials across nodes. Nodes do not relocate. They process and relay energy through the grid. Second, the carrier force, the grid's wiring that propagates information at light speed. C. Natural resistance, HPS drag. It is the pressure the grid exerts against propagation. Theory. Decouple from that drag and enter a 2C glide, an effective doubling of the usual limit. In glide, the carrier transmits without the usual pressure penalty, enabling a faster information relay. Visualize it as reduced latency from node to node, a streamlined transmission through the lattice. This remains a hypothetical mode within the model's constraints. Third, the gradient effect. Replace curvature with mechanical pressure differentials. At the bubble's hub, pressure peaks. Towards the boundary, gradients ease but continue to drive flow. Objects fall not into geometry but into pressure valleys, guided by differential contours. The recession rate reads as the grid's flow rate, 43 miles per second per megaparsec. We survey a push-pull system. Outward grid pressure meets a dark energy mesh resisting that expansion. Galaxies remain as anchors while the pressure field itself advances, carrying the recession signal. Fourth, space is not nothing. It is a high-velocity conveyor of energy and information. As speed rises, propagation meets resistance. HPS pushing back on the object's transmission path. Apparent mass increase reframed. Not mass itself, but rising propagation resistance near C. Technical survey. Measure propagation resistance directly as velocity approaches the limit. This is formalized in the graviton as node carrier framing. Mass effects from grid pressure, not infinity. Survey the universe by pressure. Nodes computing, carriers transmitting, gravity as gradients. In this model, flow is the story, and HPS writes the plot.
Imagine gravity isn't a pull at all. Imagine it's a shadow, not a spooky, stretchy shadow, more like the calm spot behind a rock in a fast-moving river. If the universe is filled with massless repulsive nodes, call them gravitons for the idea, then everything is getting pushed on, constantly, from everywhere. Two planets float in this invisible wind. Each one blocks a little of that push for the other, the way two people standing close shield each other from a strong breeze. Between them, the pressure is just a bit lower. Outside them, the pressure is normal or even slightly higher when you add up the rest of the universe. Result, they drift together, not because they love each other, but because the rest of reality shoves them into the quiet in between. That's the pressure shadow. Gravity as a net result, not attraction, just subtraction. Less push on the inside than the outside. Think of walking past skyscrapers on a windy day. In the alley, it's calmer. Step out to the street, whoosh. Planets are skyscrapers in a cosmic wind tunnel. Their gravity is the calm alley between them. Now zoom out. Picture the universe not as an empty stage, but as a giant bubble. Bubbles need two things: something inside pushing out, something outside holding shape. Soap films do that for air bubbles. What's the cosmic soap? Here's the twist: the mesh and the bubble. The mesh is like dark energy, an ultra-fine, everywhere present boundary condition, the debris of a negative sphere that once fractured and spread. It's the flexible but stubborn skin that sets the universe's outline. Inside the bubble, those massless repulsive nodes provide pressure, constant isotropic push. That inward shove you feel locally, it's just the shadow of that push, where things shield each other and create pockets of lower pressure. Why doesn't the bubble pop? Because the mesh refuses to tear and the interior pressure refuses to quit. The two balance. If the internal push slightly wins, space expands, slowly stretching the mesh. That feels a lot like cosmic acceleration. What about orbits? In a pressure shadow world, curved paths are natural, move through a sea of repulsion, and big objects carve out gradients, valleys of lower push. Motion follows the valley lines. We call that curvature. We've been measuring the map. This idea suggests a different cause for the terrain. Zoom back to two planets. The space between them is a whisper quieter. The universe around them is a shout. The shout wins. They meet. This flips the script. Mass doesn't summon a force. Mass blocks a flow. Gravity becomes the silence behind a shield, the stillness that appears when everything else is loud. A shadow you can't see, only feel in how things move. If that's true, then the cosmos isn't holding us together by pulling. It's holding us together by pushing from every direction, while objects carve out tiny sanctuaries of less push, and the whole show a bubble held taut by a mesh you can't touch and a pressure you can't escape. Step into the alley, feel the quiet, step out, feel the wind. That difference might be what we've been calling gravity all along.